Alright, dude, let's go. Number 10. The collision. In October 2024, the LIGO detector at Hanford, Washington, and the Virgo interferometer near Pisa, Italy simultaneously recorded a gravitational wave event designated GW 241011. Two black holes, approximately 20 and 6 solar masses, spiraling into each other roughly 700 million light-years from Earth. It was the closest black hole merger ever detected. The disturbing part isn't the collision, it's how close it was. At peak output, the merger radiated more power than 10 times the combined light of every star in the observable universe, compressed into a fraction of a second. Not over millennia, not over hours. In an instant, two objects smaller than a city released more energy than everything visible in the night sky combined. And it's not slowing down. But the GWTC4 catalog, published in March 2026, added 128 new merger candidates from just 8 months of data. One black hole collision every 3 days. Among them, two black holes of approximately 100 and 140 solar masses, merging into a remnant of roughly 225. Masses that no known star can produce when it dies. With each instrument upgrade, the detection horizon pushes deeper into what the dark is hiding. The universe is tearing itself apart in collisions we only started hearing 3 years ago. We're not discovering black holes, we're discovering how many we've been missing. Number 9. The missing link. In July 2024, a team led by doctoral student Maximilian Haberle at the Max Planck Institute for Astronomy in Heidelberg published a paper in Nature using over 500 archival Hubble Space Telescope images, most originally taken for instrument calibration, not science, to measure the velocities of 1.4 million stars inside Omega Centauri. It's the brightest globular cluster visible from Earth. You can see it with the naked eye on a clear night from the southern hemisphere, a faint smudge of ancient light. What makes this discovery quietly terrifying is what's sitting inside that smudge. 7 stars near the cluster's center were moving faster than the escape velocity, meaning something massive and invisible was holding them in place. The minimum mass required to anchor those stars, 8,200 suns, did an intermediate mass black hole. The long hypothesized missing link between the black holes that form from dead stars and the monsters that sit at the centers of galaxies, it's just 17,700 light-years away. Closer than the supermassive black hole at the center of our own galaxy. And Omega Centauri isn't just a star cluster, it's the stripped core of an ancient dwarf galaxy swallowed by the Milky Way billions of years ago. This black hole is the heart of a dead galaxy, consumed by ours still beating. The closest massive black hole to Earth has been visible in the night sky for thousands of years. We just didn't know what was sitting inside it. Number 8. The anchor. In 2020, the Nobel Prize in Physics was awarded to Reinhard Genzel and Andrea Ghez for independently tracking stellar orbits around the center of the Milky Way since the early 1990s, confirming that a supermassive object of 4.3 million solar masses sits at the heart of our galaxy. On May 12, 2022, the Event Horizon Telescope released the first image of its shadow, a ring of fire 52 microarc seconds across, captured by 8 radio telescopes spanning the globe. The object is called Sagittarius, a star. But what should concern you isn't the black hole itself, it's what it does to things that wander too close. Our entire solar system orbits this object at roughly 828,000 kilometers per hour. One full revolution takes 225 million years. We've completed about 20 laps since the sun was born. And in 2019, astronomer Sergei Koposov of Carnegie Mellon University found what happens when something smaller gets too close. A star designated S5-HVS1, traveling at 1,755 kilometers per second, 6 million kilometers per hour, 0.6% the speed of light. Its trajectory traces back to a single point, the immediate vicinity of Sagittarius A star. A binary star system had wandered in. One star was captured, the other was flung outward like a stone from a sling. That star is crossing the galactic disk right now. No human technology can match its speed, no instrument saw it coming. 4 million solar masses of gravity holds every star in the galaxy on a leash, including ours. Number 7, the first. In 1964, a suborbital Aerobee rocket launched from White Sands, New Mexico, picked up an anomalous X-ray source in the constellation Cygnus. By 1972, two independent teams had confirmed it as the first black hole ever identified, Cygnus X1. Stephen Hawking bet Kip Thorne. It wasn't a black hole. He conceded in 1990. The truly unsettling revelation came when they remeasured it 50 years later. In February 2021, a team led by James C.A. Miller-Jones used the Very Long Baseline Array, a continent-sized radio interferometer of 10 dishes spanning the United States, to take the most precise measurements ever of Cygnus X1. The mass jumped from 14.8 to 21.2 solar masses, 50% larger than anyone had believed for half a century. It sits 7,240 light-years away, spinning near its theoretical maximum, roughly 800 rotations per second, while actively consuming a blue supergiant companion over 300,000 times brighter than the Sun. Material spirals off the companion, superheats into an accretion disk, and vanishes past the event horizon. The companion will eventually be consumed entirely. But the detail that lingers is how the black hole formed in the first place. Its progenitor, a star of approximately 60 solar masses, didn't go supernova. It didn't explode. It didn't send a shockwave across the galaxy. It simply collapsed. One moment, a star. The next, nothing. No light, no warning. Just the dark where something used to be. The first black hole we ever confirmed was hiding half its mass from us for 50 years. It had been larger than we knew the entire time. Number 6. The Sleeper. In 1975, the Ariel 5 satellite, a British X-ray astronomy mission, detected an eruption from a previously unremarkable point in the constellation Monoceros. The source, designated as 0620-00, briefly became the brightest X-ray point source in the entire sky than 100,000 times its normal output. Then it went quiet. By 1986, dynamical measurements confirmed the source was a black hole. The implication nobody wants to say out loud is what quiescent actually means. The black hole, approximately 6.6 solar masses, is locked in a 7.75-hour orbit with a small companion star. One of the tightest black hole binaries ever documented. Every 7 hours and 45 minutes, the companion completes a full loop around something it cannot escape. Its outer layers are being slowly peeled away, spiraling into an accretion disk that currently emits almost nothing. Almost. The 1975 eruption showed what happens when the feeding rate spikes, a detonation of X-ray energy visible across the galaxy. The system held its title of closest known black hole to Earth for 36 years, from 1986 until 2022, when a spacecraft called Gaia found something hiding even nearer. But the system hasn't changed. The companion is still being stripped, the disk is still accumulating, and the next outburst is a matter of when, not if. It's dormant. It's not dead. And the difference between those two words is measured in X-ray bursts that blind satellites. Number 5, the Giant. On April 16, 2024, a team led by Pasquale Panuzzo of the Observatoire de Paris published a discovery that the Gaia collaboration released ahead of schedule, because the team couldn't sit on the data. They had found a black hole of 32.70 solar masses located just 1,926 light-years from Earth, the most massive stellar mass black hole ever directly weighed in the Milky Way. But what's terrifying isn't the mass, it's that something this large was completely invisible. Gaia BH3 emits nothing. No X-rays, no radio waves, no light. 33 suns worth of gravitational pull, sitting in absolute silence less than 2,000 light-years away. Its companion is an ancient red giant, one of the most metal-poor stars ever studied, forged within 2 billion years of the Big Bang. The black hole and its companion have been orbiting each other for longer than Earth has existed. Before this discovery, objects this massive had only been detected through gravitational waves in galaxies hundreds of millions of light-years away. Nobody expected to find one in our neighborhood. Nobody was looking. It was discovered in unreleased data that wasn't supposed to be analyzed yet. The team broke their own embargo because they couldn't believe what the numbers were telling them. 33 solar masses of gravity, 2,000 light-years away, emitting nothing. It was there the entire time. Number 4, the Neighbor. In November 2022, astrophysicist Kareem El-Badri of Harvard and the Max Planck Institute led a team that confirmed what the Gaia spacecraft had flagged in its third data release, but using 39 observations across 4 months and 6 different telescopes around the world. Here's where it becomes personal. Gaia BH1 is a black hole of 9.62 solar masses. It sits 1,560 light years from Earth. It is the closest confirmed black hole to our planet. And orbiting it every 186 days at roughly the same distance that Earth orbits the Sun is a star almost identical to ours. Same mass, same temperature, same spectral type. A sun-like star tracing the same kind of orbit our planet traces around something that produces no light, no heat, no radiation of any kind. The system is completely perfectly silent. If you replaced our sun with this black hole and placed the sun where Earth is, you would have this system. That's not a thought experiment. That's what El-Badri described in his paper. And here's the part that should stay with you. This system's formation cannot be explained by any standard model of binary evolution. The orbit is too wide. The companion is too intact. Something we don't understand made this, which means there could be more, many more, produced by a mechanism we haven't identified yet. Put a black hole where the sun is, and the sun where the Earth is. That's the system. And we found it by accident. Number 3. Spotted the swarm in 2017, a team at the University of California, Irvine, Oliver Elbert, James Bullock, and Manoj Kaplinghat published a population estimate in monthly notices of the Royal Astronomical Society. The Milky Way, they calculated, contains approximately 100 million stellar mass black holes. In 2022, Kailash Sahu of the Space Telescope Science Institute used 6 years of Hubble astrometry to confirm the first one ever found drifting alone. 7.1 solar masses, traveling at 45 kilometers per second through open space, 5,150 light years away. The number that should keep every astronomer awake is not the mass. It's the count. 100 million. We have confirmed fewer than 100. The rest are drifting through the galaxy in complete silence. No accretion disks, no companion stars, no radiation, and nothing to betray their presence unless they happen to pass in front of a distant star and bend its light for a few months. Statistically, the nearest one could be as close as 80 light years from Earth. You would never know it was there. In 2021, physicists Václav Pavlík and Stephen Shore published simulations modeling a 10 solar mass black hole passing through our actual 8-planet solar system. At 10 astronomical units, Saturn's orbit, Earth is pushed outside the habitable zone. At 0.2 astronomical units, the system is destroyed entirely. Transit time across the planetary region at 30 kilometers per second, approximately 25 years. 100 million. We found fewer than 100. The other 99,999,900 are still out there, and the dark isn't empty. It never was. Number 2, The Visitor. And Avi Loeb Ausumson, Frank B. Baird Jr. Professor of Science at Harvard University, founding director of the Black Hole Initiative, calculated the probability of a stellar mass black hole encountering our solar system over its 4.6 billion year lifetime. He used the local density of stars in the Milky Way's disk, the estimated population of 100 million black holes, and their typical velocities. This isn't a hypothetical, the math says it already happened. Over the lifetime of our solar system, at least one stellar mass black hole entered the outer envelope of the Oort cloud at roughly 20,000 times the Earth-Sun distance. The encounter lasted tens of thousands of years. Imagine it. A 10 solar mass object, invisible, drifting silently through the outermost boundary of our solar system for longer than recorded human civilization has existed. Cometary nuclei, billions of icy bodies weakly bound to the sun at those distances, would have been gravitationally scattered, some flung outward into interstellar space, others redirected inward toward the planets, toward Earth, arriving as a slow rain of impacts spread across millions of years. Some may already have hit. We would have attributed them to other causes. A black hole already came. It passed through the outermost edge of our solar system, spent tens of thousands of years inside, and left. We have no record of it. We have no evidence it won't happen again. And next time, it might come closer. Number 1, The Ghost. In September 2024, physicists Tung X Tran, Sarah R. Geller, Benjamin V. Lehman, and David Uffers Kaiser at MIT and UC, Santa Cruz published a paper in Physical Review D that changed what nearby means. Their calculations showed that if primordial black holes, objects formed in the first fraction of a second after the Big Bang, constitute the dark matter of the universe, At least one passes through the inner solar system approximately every decade. Every other entry on this list is something we found. This one is something we can't. These objects are smaller than a hydrogen atom, heavier than asteroids, traveling at 240 kilometers per second, faster than any spacecraft ever launched. They carry the massive mountains compressed into a point smaller than anything your eyes could resolve at any magnification ever built. And they leave no trace, no light, no heat. No gravitational signature large enough to register on current instruments. In 2025, a team at MIT proposed that a primordial black hole may have exploded within 2,000 astronomical units of Earth, inside the Oort cloud, producing a 220 peta-electron-volt neutrino detected by the KM3NET Observatory in February 2023. If confirmed, it would be the first observation of Hawking radiation in history. In 2020, physicists Jakub Scholz and James Unwin proposed that the object inferred from anomalous trans-Neptunian orbits, the one we've been calling Planet 9, may not be a planet at all. It may be a primordial black hole the size of a grapefruit, 5 to 10 Earth masses, orbiting the Sun at 300 to 1,000 astronomical units. As of 2026, the hypothesis has not been disproven. And in 2025, but physicist Robert Scherer of Vanderbilt University calculated the threshold for a primordial black hole passing through a human body. Above a certain mass, the passage is lethal. Below it, you'd never feel it. The dark passes through you. And you don't even know there is something smaller than an atom, heavier than a mountain, and faster than anything you've ever seen. And it may be crossing between Earth and Mars right now. No telescope can see it. No instrument can hear it. The dark you thought was empty has been moving through your solar system your entire life. And it has never once announced itself. If you want to see more videos like this, click the video on screen now and make sure to subscribe.